So we need to find the sloppage of the line that passes through these 2 points. And then we're going to review the 2 lessons that I was absent for with the homework. So if you have the homework, it should be easy to follow along. If you don't,
did the homework instead of.
So let's go ahead and figure out the sloppage between these 2 points. So sloppage is always going to be a fraction of some sort. Even if the denominator is 1, we can still keep it a fraction. So I'm just going to go from 20 to negative 2. So if I went from 20 to negative 2, I would have to go down. So that's in the negative direction, 22. So that's my numerator, negative 22. Finally, in the denominator, I'm going to find the change in the x's. So I would go from negative 50 going to the right to 3. Means I would go to the right, so that's in the positive direction, 53. And that would be our denominator. So from here we got to check and see if this can be simplified. Nope, it cannot. That is all. So that is our sloppage. So number 1 here, show that the equation for a line that goes through the origin and has a sloppage of negative 3/5 is y equals negative 3/5 x. So we're going to have to use that proportion stuff like we did in the lesson. And let's go ahead and do these. So from the origin, we're going to have a sloppage of negative 3/5. I'm going to make that a negative 3 over positive 5, which means I would go down 3, 1, 2, 3, and I would go to the right 5, 1, 2, 3, 4, 5, right here, which would give me this point. Now I'll just connect these to make a line. Alright, there we go. That's a pretty good line right here. Nice. And if it helps, you can draw your little right triangle like we did in class. Negative 3 and 5. Well, from here all we got to do is choose a point on the line right here. And what is its point value? Well, it has a value of x and a y. Like these. And it gives us another right triangle right here, which is proportional to this other right triangle right here, which was discussed in the video, which you guys apparently didn't watch. And that's okay, that's why we're doing it right now, right? So it's proportional, which means that we got these 2 fractions, and it's always some y value over the x value. So I'm using the point from the purple point right here. And then what is the fraction from this red point right here? Well, it looks like it was negative 3 is the y, and the x value is a 5 right here. And we're solving for y in this case, right? I mean, this is what we're trying to get, is a y. Y equals negative 3/5 x. So what would we do to solve these? I would multiply both sides by x so that these 2 x's cancel. And what do I have? I got y equals negative 3 over 5 times x. That's exactly what we have up in here. And that's it. That's all we had to do. Bam. So negative 3/5 is the sloppage, which is, it was pointed out up in here. The nice thing about that is when we get into word problems, which is what it looks like is coming next, is if we can find the rate of change, that's all the sloppage is a constant rate of change, which is also shown on the red poster over there on the east wall, but no one ever looks at. That's all we got to find, and then we can write this stinking equation, okay? Because ultimately, the equation really is just a y equals whatever the sloppage is, right here, and multiplied by x. That's it. That's all that is. Now, again, the sloppage can be the rate of change. And then would have the equation for that case. All right, number 2. Bruce rents snowmobiles to tourists. He charges $135 for a 4-hour and $202.50 for a 6-hour. What is the hourly rate that Bruce charged to rent a snowmobile? Well, right there they just, we can see that to go from 4 hours right here to 6 hours is a change of 2 hours. 2 hours. Okay. And it also went from $135 to $202.50. So we just need to find the difference between these two. And that will tell us the change in the cost over the 2 hours. So we'll subtract at these. You can put some zeros there if you want. Some good old 50 cent. That's going to be a 7. Carry the 1 and the 9 is 6. And I have to borrow from the 1 there as well. There we go, $67.50 for the 2 hours. Well, if we wanted to find his hourly rate, so this is $67.50 forever 2 hours. But what we want to find out is how much it cost for 1 hour, because that's the hourly rate right here. Well, how would we do that? Here's what I would do. I would divide 2 by 2 to get to 1. So I'm just going to divide the $67.50 by 2. And what do we get up in here? Something like a 75 cents, right? 33.75. Oh, wait a second. Per hour. There we go. $33.75 per hour. All we want is a sloppage and the y-intercept for these. So that is what we will do, one at a time. Now remember, if we can get this into what was slope-intercept form, that's y equals mx plus a b, where m is the sloppage and b up in here, that's the y-intercept. But we have to be careful with how we write that. So the sloppage on this one, it looks like that is corresponding with the 4. It's just the coefficient of x, you guys. So the sloppage is 4. You can make it 4 over 1 if you want. And then our y-intercept, one of the problems we run into for the most part on tests is that people like to write just 1. If you do this, you're going to miss points because the y-intercept is a point on the line. It is an ordered pair, 0, 1. So you need to make sure that you write these as ordered pairs like these. If we look at this graph right here, the y-intercept, that's 0, which is in green right there. The y-intercept right here, the b, is 1 here, right? That's the value of y on the y-axis, which is 1 right here, right? Well, that's just the value of the y. The x value here is 0. In other words, if we made this a point, it would be considered 0, 1. Now this line, of course, is pretty steep, something like this. So it's just the point on the y-axis where the line crosses the y-axis. So yeah, the x here on the y-axis is always going to be 0.
Always.
So for any y-intercept you write, always just put the x value as 0.
Oh yeah, and good question.
All right. So again, we need to identify where the sloppage is, or what it is, and then the y-intercept on it, these. And again, since we know the y-intercept is always going to have an x value that's 0, we'll just fill in the rest. Who can tell us what the sloppage is of this equation? Very good, negative 3. It's the coefficient of x, the number being multiplied by x. And the y-intercept is the value that's being added. Right account, right? 5. So let me ask you this, because usually we're seeing stuff in this y equals mx plus b stuff. That slope-intercept form, is number 4 in slope-intercept form? Nope. So we do need to manipulate this thing so that it will be in slope-intercept form. So what do we got to do? We need to make it y equals some stuff. But right now we're adding some kind of negative x. So we got to get rid of that x by adding x on both sides. See what that's going to do is it's going to change this negative x plus x. That's a 0 now, which we don't usually show. And we get y equals 4 plus x. For some of you, that's good enough to see what the sloppage in y-intercept is. For the rest of you, you still wanted this form, right? So we can use the commutative property to change this to y equals, now we got the x, and now I'm going to add the 4. See how I just changed the position on those? Commutative property. Who can tell us what the coefficient of x is right here? Austin? 1. That's a phantom 1, right? We don't see it, which is kind of creepy, but it's there. Okay, it's definitely there. You know, if you get creeped out by it, just beat it up, all right? In any case, now we should be able to identify what our sloppage is. What is the sloppage up in here? Oh, 1. It's just the coefficient of x, you guys. And what about the y-intercept? That's very good. 0, 4. Not 4. With parentheses, yeah. That's good. Yeah. All right, thank you. Good luck.
Okay.
You can, I don't care.
So it's in the correct formula, which is y equals mx plus b. That's the b. Like negative 3 is the b. So then from that you can say the y-intercept equals negative 3, and the slope is 5/6.
Bam. Nailed it. I go.
So the formula would be mx equals b, and then the intercept would be 0, negative 7, then three.
All right. Very nice. That is correct. Very good. So we need it to be y equals mx, and that would be plus b right here, right? So right there we got y plus 3x, so that's no good. No good, all right? So what we got to do is subtract 3x. By the way, remember, it's okay to get stuff wrong right now, right? This is just review, some practice stuff. So it should help us to see what to do and what not to do, and that's good, okay? All right, so then we got y, because this 3x stuff cancels out, right? Count right. So then we got y equals negative 7 minus a 3x, which would be the same as a y equals negative 3x minus 7. So I just move those terms. Well, what do we need to change about the answer then, you guys? What's the y-intercept? I'm looking down here, by the way.
Down where?
Down there in the bottom right.
The y-intercept?
Negative 7.
0, -7. Well, that's what we got. That's good.
Where did you get the 0 from?
All right, what about the sloppage? Do you guys not know what a coefficient
It
is?
should still be like negative coefficient.
Yeah,
is
it
the
becomes a
number.
-3, but does anyone not know what a coefficient is? How many guys are too ashamed to say you don't know what a coefficient is? Like that's the deal breaker on if I look stupid or not.
I'm stupid then.
No, don't feel stupid. I'm not saying you should.
I mean,
I'm just saying, like, if you do and you don't know what a coefficient is, don't.
I noted it.
But you need to let me know if you know or not, okay? A coefficient is just a number that's being multiplied by a letter. Well, right here, the -3 is the number being multiplied by the letter. Yeah, that's good. So let's say that as y-intercept you wrote y equals 0, -7. I got to take points off that, okay? That looks like you're trying to write an equation in a really wrong way. See, the equation is y equals mx plus b. What you found there is the y-intercept, and I can kind of tell that on a test. But you've done it in a very, very poor format, so don't write y equals nothing. If you wrote b, that'd be fine, because b represents the y-intercept.
So right.
If you wanted to write all the words like y-intercept, I'm okay with y-int. I mean, I get that. But some of you guys really like to write stuff, so you can write the whole thing, intercept. But if you spell it wrong, I really don't care either. That's why math people created all these little shortcuts and symbols for you guys, so that you wouldn't have to write all the words all the time. Right? They got tired of writing y-intercept, so why should you write it all the time as well? 7 is extremely difficult. We look at 7 and we kind of want to quit because of what? A fraction, right? Like, oh, there's a fraction. I don't know what the heck to do. I give up. No, don't do that, all right? This one is already in sloppage intercept form, which is great. All right, good luck.
Thank you. So, we already know that x equals 0. So then from there we really can just go 2 which equals b. B equals 0 2 close parentheses. And then we also know that this right here is the sloppage. So we just go m equals 1/5. Done.
Excellent. I noticed you chose a great color. All right, numbers 9, 10, and 11. These ones are pretty crucial because in ninth grade, if you can't graph equations like these, linear ones specifically, then they're going to mark you wrong and devastate your life. So it's important, highly important, to know how to find the y-intercept and then use the sloppage to find all the other points. All right, so here's old number 9er. And can someone tell us what the sloppage is right here? Yeah, -2. Now I am going to make that a fraction so we can see how far up and down we go and how far to the right and left. So I'm going to make that -2/1. Is everyone okay with why it's over 1? It's kind of like the identity property for division. Okay. Well, then let's identify the y-intercept up in count. So it should be 0 something. What's the y value? 2. Very good. So that's what I need to do first, is graph the y-intercept, which is at 0, 2. That would put me right here. Now what I'm going to do is I'm going to use the sloppage to find the other points. And this one, since it's a negative, I'm going to go down 2. So from this point, I go down 2. Bam, down 2. And then the one is positive, so I'm going to go to the right.
Go to the right.
1. And that puts me at this point right here. This gives me the next point. Now that gives me some stair steps to graph on here, so I can find all the other points on a day's graph. Down 2 to the right 1. But I don't have any points to the left of the y-axis. But I can keep building those stairs to find these other points, okay? Now all I got to do is connect them. There it is.
We got our homework stamped already.
Nailed it. Good luck.
I know, I just like saying that because then I feel sophisticated. Anyway.
Don't worry, one day you will have a job.
So, you get the -3, and since that is actually equal to b equals 0, -3, you go 1, 2, 3 right there, and you go -1, then to the right 1, down -1 to the right, then -1, 1, -1, and 1 right here. You scroll up, dang it. Oh well. So, from there, you pretty much just draw the line. And that's your slope graph line.
Oh, how'd you get a negative sloppage on that?
What?
How'd you get down 1 and to the right 1 on that thing?
Because, one sec. I didn't do that right. I forgot to simplify first. Minus x, so y is equal to -3, sorry, minus 1x phantom 1. Yeah.
Okay.
Go down 3, then -1 over 1.
Very good. Very good. Excellent. Let's address this. So originally we got y plus x equals -3, right? Well, and he pointed this out, we need to subtract x from both sides. This kind of helped me skip a step right here. Now I got a 0 right here, 0 pair. I got y equals -x minus 3, and yeah, there's a phantom 1 right there.
Oh, I see now.
But we make it a -1 over 1. This right here is our sloppage. There's something we need to fix, though, on this. Did anyone catch that right there? All right. Now, he said it right. It's just we need to go down to 0, -3. That's all.
It's on -2.
Yeah, it's on -2. That's okay. I mean,
Oh, okay, yeah.
that's very small, but I mean the rest of the points. All we need to do is translate that line down 1 unit, and then we would get this line. So it's not a problem, but just be aware that
I didn't do that on my paper.
it's okay.
Okay.
I'm just pointing it out so that we can address it, because I don't want you guys to make the same mistake on the test, and we gotta worry about what the heck is going on there. All right. So be very careful. All right, this one is extremely tricky, because now it's 1 equals y minus 2/3 x. But the concept remains the same. I'm going to need to add a 2/3 x right here. And I'm going to need to add 2/3 x over here. So that becomes a 0 pair right there. Just to move this over here so I have some more space. What I have is 2/3 x plus 1 equals a y. I forgot my 1. There it is. Well, some people get really confused with this because the y is on the right side of that equal sign. That's okay. Just know that it's the same thing as writing it as y equals the 2/3 x plus a 1. Which is great now because we found our sloppage, which is up 2 to the right 3. And the y-intercept is 0, 1. Bam. So let's start the graph up in here. I got a point at 0, 1. And then my sloppage tells me to go up 2. And then to the right 3. Right, the little stair steps like these. And then the next point would be off the graph somewhere over here. But I can continue the pattern going to the left. And that would give me this point right here. And then, of course, all we need to do is connect points. That looks pretty good. Nailed it. All right, the entrance fee to the national park is $15. A campsite fee is $15 per night. The total cost for a camping trip for X nights can be represented by this equation, which they gave us, right? Is so y equals a 15x plus 15. That's great. You didn't even have to figure that equation out. They just gave it to you. Now let's go ahead and graph that equation. All right, so before we graph this, we do need to identify what our x value is representing and what the y value is representing. The y value, based on the word problem, is the cost in dollars. I put that in the wrong one. Let me switch those. The y value is cost. And the x value, can someone tell us what that represents by having a seat?
Oh, sorry.
Yes.
The number of nights.
Yeah, number of nights. Very good. The number of nights. So now that we have that, we should be able to label this. The y is the cost. And the x is the number of nights. So, based on the equation, what is the y-intercept? 0, 15, right? So let's graph that point right about here. And then what is the sloppage? Well, that's the coefficient of x, which is this 15. I'm going to make that 15 over 1 so we can see the sloppage. So from this point, I'm going to go up 15. That takes us up to 30, and then to the right one. That's our next point. Up 15 to the right one. That's the next point, 345 rather. Then up 15 to 60 to the right one. That's the next point. Up 15 to the right one is the next point. Up 15 to the right one. Bam, there we go. Now we just need to put a line through these points. That's pretty good. With graphing like this, see on that top point how I kind of missed the line with the point there, that top point? 590. So what do you do if you miss the point when you draw the line?
Make it bigger.
Yeah, you just make it a bigger point. There we go. So we got the graph. Use the graph to find the total cost for 4 night. Okay. Well, we can see on the x-axis this represents 4 night, which would take us up to this point, which appears to be 4.75er. So that would be $75. Interpret the slope and y-intercept. Well, they kind of told us in the word problem. The sloppage. Sloppage is the cost, which, actually I take that back. It is cost. But more specifically, it would be $15 per night. And the y-intercept is the $15 fee. Specifically the entrance fee. But entrance is a long word and I don't want to write it. Geometry. Write the equation in sloppage intercept form. Okay, they gave us the equation. It's right there. So how do we change this in the slope-intercept form? Well, we want it to be y equals mx plus b, so I'm going to have to subtract x from both sides. Like this, that cancels the x. And I got a y equals a 90 minus x. Still not really slope-intercept form. What I need to do is make that a negative x. And then I'll add the 90. So I just switch those two terms. Still y equals though. And if it helps, you can put a 1 in front of the x. Bam! We got it. So the equation in slope-intercept form, y equals negative 1x plus good old 90. Now let us graph this equation. So the x value is just some number of degrees and y some number of degrees. We can label those. So this is degree. And the x value is also degree. Since this is 90 degrees, you guys should learn this in 7th grade. That makes that a complementary relationship. But whatever, all right. Again, we got the sloppage y equals a negative 1x plus 90, which we will use to graph. All right. So what is the y-intercept on at these? I got 90, 0, 90.
Yeah.
That's our y-intercept. So I can graph that point right here.
And since since it's like negative 1/1, can't you just go by 20s then?
Sure.
As long as you keep it.
Oh,
same.
sure. Yeah, so this is a negative 1/1, but we can make it a proportional relationship. I'm going to do it by tens.
Okay.
Down 10 and to the right 10. The reason I'm doing that is because our scale for the y-axis is in tens, and so is the x-axis. So that makes it extremely convenient. I can go down 10 and to the right 10. Bam, there's another point. Down 10 to the right 10, and then all these corners are my points for this. And so I just need to put these down as points,
Point.
and then I connect them in order to draw my line. There it is. That's pretty. That's pretty good.
That's pretty. It looks like a Christmas tree.
My class.
All right, use the graph to find the value of y when x is 30. Well, x is 30 right here. And if we go up to the line, we have this point, which is a y value of 60. We could label that in degrees because it is a word problem, though, kind of. All right, so do you guys want this immediately in slope-intercept form, or we'll make it in slope-intercept?
Immediate.
All right, that sounds good. All right, so we'll do y equals, you guys give me a number.
7.
Let's make it a fraction. 7 over
2.
20 is a big number. Let's make it 2. That's good.
7.
7x, you guys want a plus or minus?
No, it should have been 11.
Minus,
Fraction is the best.
minus what?
want a frozen slushie.
4.
Minus 4.
7. Negative 4.
All right, from this, we can see that the sloppage is going to be 7.5. And then the y-intercept is
4.
0, negative 4. Very good.
Negative.
So when we go to graph this thing,
Negative 4.
so
Close.
gra-
On the computer. That's how I got first place in that coding.
all right, so from this equation, we got our sloppage, we got our y-intercept. Now we just need to start some graphage. So I'm going to go down to negative 4. 1, 2, 3, 4. And I got my point right here. All right, so I'm going to go up 4. 1, 2, 3, 4, 5, 6, 7. That's my up 7 from the sloppage. And then I'm going to go to the right 2. Bam, 1, 2.
Wait, wouldn't you go?
And that gives me a point right here.
above the x-axis?
Well, no, you go up 7 from the y-intercept is where you go from.
Sorry.
Now, if this were a bigger graph, we could put on some more points, but this will do it for now.
Sorry, I
So I'm just going to put the graph on here,
I thought so. First.
and we'll get something like this. All right, you guys give me a value. 8. Make it a fraction. Oh, not 1. Whatever. We'll make it 3. We'll make this a negative 8. 8/3 x plus or minus a y. Minus a y equals what? We'll make it 3. Otherwise my graph has to be humongous. All right. Well, on this one we're going to need to solve for y, meaning we want it to be y equals some stuff. So the first thing I'm going to do is add. I'm going to add an 8/3 x to both sides. So plus me some 8/3 x. And then I got negative of y equals, I'm going to reverse these or use the commutative property right now. 8/3 x, and that's a plus 3. Well, from sloppage intercept form, we want it to be y equals some stuff, not negative y equals some stuff. So, what are we going to do? This coefficient of y is a negative 1. To get rid of it, we're going to divide everywhere by negative 1. Really, all that's going to do is change the signs. So, now we got y equals negative 8/3 x. Instead of plus 3, it's a minus 3 now. So, from here, we should be able to find our sloppage, which is a negative 8, and I am making the 8 negative on purpose. Over 3, and then we got a sloppage of y-intercept now of 0, negative 3. But we need to graph this thing. Okay, let us go down to 0, negative 3. So that would be about right here. 0, negative 3. And my sloppage tells me to go down 8 from this point. So I'm going to go down 8. 1, 2, 3, 4, 5, 6, 7, 8. So I went down 8. And then I'm going to go to the right 3. 1, 2, 3. Which puts me about right here. So from this stair step, by the way, right, we got this stair step. We could make one going in this direction as well. So in that case, if we wanted to, we'd go up 1, 2, 3, 4, 5, 6, 7, 8, and then to the left 3 up and here. So that would give us this point right here, or something like that. Make that really big. Of course, from this point we could go down 8, 1, 2, 3, 4, 5, 6, but I can't go down that far. So I'm good with that, and the graphs should tell you what values to use. So that line will do it. Slope will always be a fraction. I believe we did this last time or one time before, sometime, where we use this rainbow type method, all right? We're going to connect the x's and the y's. The y's go above, and to go from 21 to negative 4, you'd have to go down 25 right here. So we went down 25. And then from the x's, you go from negative 3 to 17, which would be to the right, so that's positive 20. Like these. Well, that would be good enough, but this one can be simplified by dividing both of these by 5. And then we get a negative 5 over 4. That's it. That's the sloppage.
Yeah, I get it now.
All right. You got Bruce, who rents snowmobiles to tourists. He charged $135 for 4 hours and $202.50 for 6 hours. What is the hourly rate Bruce charges to rent a snowmobile? Snowmobile, there we go. So, right here, we can see that in 2 hours time, because it was 4 hours to 2 hours, 6 hours rather, that's 2 hours of time. Okay? On the other hand, in those 2 hours, the price increased from $135 to $202.50, like these. So we're just going to find the difference between these two to see how much it changed. So in the 2 hours, it looks like it changed by subtraction. We're going to carry 1 over here. We'll borrow from 2 as well. 7 and a 6er. So it looks like it was $67.50 in 2 hours. But that's not what we want. Down here in the bottom, it says, what is the hourly rate Bruce charges to rent a snowmobile? So we really want to know how much it costs for 1 hour. So to do that, we would divide the 2 hours by 2, which means we need to divide the $67.50 by 2 as well. What this will do is it will tell us how many for 1 hour. And it appears that looks like it'd be about 75, 33.75. $33.75 for 1 hour is the hourly rate that Bruce Wayne charges for snowmobile rentals. The power absorbed by a solar panel varies directly with its area. Alright, so we got some direct variation, so we got some equivalent fractions, some proportion. If an 8 square meter panel, so I'm going to put my square meters up in the numerators. So I got an 8 square meter panel absorbs 8,160 watts, so my watts are in the denominators. Then how much does a 12 square meter panel absorb? We don't know how much absorbs, so I'm just going to use an X. You can solve this one any way you like. Now you could find the unit rate like we did on the last one and then just multiply it by 12. That's completely up to you. So what I'm going to do is just solve a proportion because this is all 7th grade stuff and you guys loved it. I like old fishy method.
Yay!
And then we got a fish, right?
Darn sweat, Skylar.
Alright. Well, now it's covered the problem, but we got 4 values. Multiply, divide, and equals. And the first value we got was 12, then 8160. And then an 8, and that should equal our x. Using old fishy method. Well, if I plug this into my calculator, I get 12,240 watts.
Hey, do that. Wait a minute. I think I got that right.
Now, if by chance you did find the unit rate for this one, it would be 1,020 watts per 1 square meter. And then you can just multiply that by 12 to get 12,240. So this one, number 5, we're going to determine if that is a direct variation. We'll do 6 as well. So right here, hopefully you guys remember from a few classes ago that if we compare all the y values and divide them by the x values, we should get the same equivalent values. So on this one, we got 95 is the y value because the y is in the bottom part of this table. And I can divide it by the x, which is a 5. And if I found the value of these, I would get 19. Well, what about the next one? So we're going to make these all fractions, unless we find any of them that aren't equivalent. So I got 190 divided by 10. What does that equal? 19. So those are equal. That's good. What about the next one? 285 divided by 15. Yeah, that should come out to 19 as well, so that's equivalent. And then finally, we got this 380 divided by 20, which comes out to 19. These are all equivalent. So this one is a direct variation. This one is a direct variation, which means it's proportional. As we can see, we have many equivalent fractions. And the constant of proportionality, which it wanted us to tell us what it It's just the reduced form of the fractions, which in this case is 19. You could make it 19 over 1 if you wanted, but that's the constant of proportionality. Seems like there's a song about that, right? Like some kind of heavy metal song, the constant of proportionality. It's the constant of proportionality. I don't know, whatever. Maybe it was the constant of variation. That's fine as well. It's the same thing. All right, what about this one? Is this one give us a proportional or direct variation? So I'm going to take my y value, which in this case is 28, and divide it by 3. All right, well, 28 divided by 3, that would be 9.3 repeatant. Well, what about this next one? This one is 40 divided by 6, which should be about 6 point some garbage. But these are not equal anyway, so as it turns out, we would just say that this one is not a direct variation. Bam. If y varies directly with x, write an equation for the direct variation, then find each value. Okay. If y varies directly with x. Well, they're saying it does. So we will write an equation for these. I prefer to write these as proportions, but you don't necessarily have to. So I'm going to keep them this way. Here we go. I got my y value when my x is 1. And then I got a y value is 3 when x is 2. Bam, there it is. This would be a good enough equation for me. And then it says to find the y value. To solve this, I would just multiply both sides by 1. And then I would find that y equals 3/2. Number 8, find x when y is 18. So in the fraction, I got an x in my denominator when my y, my numerator, are 18. And then it tells us that y is 5 and x is 4. So you could, if you wanted to, and this is fine for the equation, by the way. If you wanted to, you could use Fishy method, cross multiplication. We haven't used cross multiplication, I don't think, yet. So let's do that. 18 times a 4. What do we get out of this? 72 equals x times 5, so that'd be a 5x. And now to solve this, I would just divide both sides by 5. And then I get x equals 72/5. Yeah, that'll do it. I don't really want the mixed number. The decimals, a little bit more work than I want to do as well. There it is. There's all of it, except for the other ones. All right, this one is one of the more difficult ones because it's got a fraction,
No, it's easy.
which makes it extremely difficult, right?
No, it's extremely easy.
You know what? When we see fractions, we just want to tap out, man. Like, they got us in an arm bar, and it's time to tap out. Otherwise, that thing's going to snap right in half. So, we see those fractions, and we like to give up. But if we just remember that it's y equals the sloppage, which is represented by the Greek letter m, times the x, and then we're going to add b, which is the y-intercept, then hopefully it's not too bad. Because we can see the m, which is the coefficient of x, and I said the word coefficient knowing that you guys probably forgot what it means. A coefficient is just a number that's being multiplied by a letter. In this case, 5/6. Is the coefficient. That's the sloppage, 5/6. And then the number that we're either adding or subtracting is the y-intercept, b. But here's the problem that we find, especially on tests, is that for the b, you guys write -3, correct? Wrong! If you do it, you're going to lose points. The y-intercept, whatever. The y-intercept is a point on the graph, so we need to indicate that it is a point, and the x value is always 0.
What? I don't get
So yeah, exactly, y. It's the y-intercept. That's a good point. Okay. So in this equation, we would get something maybe that looks like these, right? Well, the y-intercept is where that, I have it in purple. The purple line crosses the y-axis right here. And what's the value of that point? Well, the x value is 0, and then the y value in this case is -3. That is why we have to show it as an ordered pair, a coordinate pair, a point, x value, y value, whatever you want to say there, it's fine. All right, right there we have two angles that add up to 90 degrees because it says that x plus y is 90. Now, that's all 7th grade stuff which you guys have forgotten because of the summer and now fall. But when we have two or more angles that add up to 90 degrees, that is a complementary relationship. We're just going to find the graph of what that looks like, which is, it's pretty, okay? So write the equation of the sloppage and slope-intercept form. This right here is the equation they gave us. It is not in sloppage-intercept form. I do have a poster
I
for...
was so confused on that one. I have no idea how to do it.
Well, good. That's why we're doing it. In fact, I have a poster with this type of equation for linear equation.
Wait, why is it in the poster above the
This one is called standard form. The poster for that isn't imperative right now that we know that, but we'll get to it, okay? In the meantime, let's go ahead and manipulate this so that it will become slope-intercept form. So what we need it to be is to be y equals some garbage.
No, y equals mx.
So right up here, we got x plus y. That's no good. We got to get rid of that x. So let's subtract x from both sides. Well, what does that give us? It gives us a y equals a 90 minus x. But some of you guys would be fine with that form. But I'm going to change the position of these two terms. I got a negative x term, and then I got a positive 90 term. Well, this now is in slope-intercept form. Some of you guys look at that negative x and think, well, there's no number in front of the x. There is, it just can't be seen. It's a phantom 1. We can put that there if we want. Some of you guys may think that it's kind of creepy that it's there, you know, kind of spying on people, which is kind of weird. But in any case, it is there. If we want to, we can make it go away, but it's still there, okay? We just can't see it. Sometimes we can't see it, like we do right here. So based on what I told you guys about coefficients, what is the coefficient of x on this one? -1. That's very good. So keep that in mind. This right here would work as sloppage-intercept form. All right, there's our equation. Let's graph it. Well, I'll zoom in on this thing. All right, the first thing we're going to want to do is to label the xi. And x was represented, if you remember, in degrees. And y was represented in degrees.
What?
Because they both represented the measurement of some angle. Well, based on this one, this equation specifically, who can tell us what the y-intercept is?
1.
Yeah? Close. Yeah?
0 across, in parentheses, 0, comma, 90.
Correct.
Comma.
Very good. Now if we were to graph this point, which we can do, well, let's graph this point 0, 90. I got right here. Well, if that's the case, who can tell us what the sloppage is?
No one knows what a sloppage is. I know what the sloppage is.
Yes,
It's rise over run.
that's close. I just wanted the value of it. Yeah? Bam. No.
No.
No. Yeah,
-1 over 1.
that works. -1 over 1. Now here's the problem with -1 over 1, though, is that this graph is too big. The scale is too huge to find -1 over 1. So I'm just going to change the values of these. I'm going to scale it up, but it will be equivalent. I'm going to make it negative 10 over positive 10, right here. What that means is I go down 10 on my scale and to the right 10. That gives me this point right here. Then I can keep going down 10 to the right 10, down 10 to the right 10, all the way until I reach the end. And that gives me these points right here. Oh, thank you. All over these. And now in order to graph these, all I need to do is put a line up in here. Bam. Alright, there's the graph. That looks really good. Alright, the next part, it tells us to use the graph to find the value of y when x is 30. Well, x is 30 right here. So I'm just going to follow this line up until I get to that line, which is right here. And I can see that the y value is 60. 60 degrees, really. So when x is 30 degrees, y is 60 degrees.